Let me introduce today's plenary speaker, Ross Methuselam. Ross is an academic ambassador for JUMP, helping university faculty to apply JUMP in their teaching and research. As Ross will tell you, JUMP is fast, and it operates at its fastest when paired with a user who knows how to use it effectively. In this talk, Ross will share strategies to boost your speed using JUMP, including shortcuts, time-saving features, and best practices for efficiency, so you can make discoveries with speed squared. Take it away, Ross.
Great, thanks for that introduction, Jeff. And everybody, thanks for joining us to learn some speed boosting tips in JUMP. And I'm going to show you these tips in the context of data analysis on speed, in particular wind speed. And why wind speed? Well, I happen to have a superstition, so let me explain. I live in Tampa, Florida. We're on the Gulf of Mexico, and the Tampa Bay region is known for sunshine and palm trees and beaches. I'm actually showing you right now a picture of downtown Tampa, or at least part of it, from across the Hillsborough River. And I chose this picture because it actually depicts the Kennedy Boulevard Bridge, which is where this story begins. I first moved to Tampa in 2016 and lived downtown, and I crossed the Kennedy Bridge almost every day. And about in a year into living in Tampa, I saw the Kennedy Bridge on TV and was so shocked by what I saw that I actually took a picture of my TV in that moment. So here's that picture. You see the Kennedy Bridge situated behind a relatively concerned-looking Anderson Cooper as he warned of the impending arrival of a monster Category 4 storm barreling towards South Florida. That happened to be Hurricane Irma, packing wind speeds of about 130 miles an hour. Now, I was new to Florida, knew almost nothing about hurricanes, but I knew that if CNN was going to send Anderson Cooper to my neighborhood to report on a hurricane, that I should probably get out of there. So my wife and I followed our evacuation order and we left, and luckily things were fine, as at least for us, as Hurricane Irma made landfall a little south of us, more near the Naples area. So that was back in 2017. And since then, we've gotten some more experience with hurricanes. In 2020, we had Hurricane Isaias, which was projected to make landfall, or at least pass over Tampa for a little while, before ultimately skirting up Florida's east coast and making landfall in North Carolina. Fast forward 2 more years, and we had Hurricane Ian, which was projected to go right up the Tampa Bay and actually make landfall near our house, but ultimately swung a little farther to the south and made landfall in Fort Myers. And then just 1 year later, and about 1 year ago, we had Hurricane Idalia, which made landfall in Florida's Big Bend region, but brought a lot of heavy rain and flooding to Tampa, flooding that actually came within about a mile of the house that I live in right now. So since Hurricane Irma, I've had a fair bit of experience with what we'll say near misses with hurricanes. And with each of these, I noticed a particular trend. And that's that the name of each of these storms began with the letter I. And so I've developed a bit of a superstition around what I'm calling I storms. That is, these I storms are out to get Tampa, and it's only a matter of time before one makes direct landfall right where I live. And so I thought I would look into some data to try to answer the question, how bad are I storms really? That is, if according to my superstition, it's only a matter of time before one makes landfall basically at my house, I would like to know, how strong are these storms? Are they stronger than average or maybe worse than average? I certainly hope the latter. And to answer this question, we're going to look at wind speed data, because wind speed is how we categorize hurricanes on the Saffir-Simpson scale, where a Category 1 hurricane is 75 to 95 mile an hour winds. But as we get up towards Category 4 and 5 storms, we're all the way up towards 150 mile an hour winds. And as you can see in this simulation, we're talking about some real destructive force here. So I would like to try to determine how bad these I storms are to maybe assuage some of my fears, given that I'm pretty sure one is coming for Tampa eventually. So we're going to answer that question and in the process show you some tips for boosting your speed with JUMP. And we're going to do this pretty fast too. Over the next 20 minutes, I'm going to show you a speed boosting tip a little faster than one every 90 seconds. So I want to encourage you to sit back, take note of what's possible, and remember that you can always go back to the recording of this talk on the user community at community.jump.com to review it at your own, perhaps slower pace. So with that, let's head on over to JUMP and get started. And I'm actually going to start with raw data here, because boosting your speed with JUMP starts with data import and preparation. So here I'm looking at a folder full of Excel files, one per year, starting in 1950, the first year where storms were actually assigned names, all the way up to 2023, the most recent complete Atlantic hurricane season. And so here's an example of what the raw data looks like. You can see we have storm name. We also have max wind speed, among some other variables. I got these data from the Weather Underground, that being the online weather service, of course, not the 1970s militant organization. And if you're interested in hurricane data or other weather data, I recommend going to NOAA, the National Oceanic and Atmospheric Administration, which I did at first. And they have some very rich hurricane data, but perhaps just a little more complex than we need for this simple example. So let's start by bringing these data into JUMP. Now, I have over 70 Excel files. And so if you're a brand new user, you might think, I need some way to stitch all those together before I could use JUMP to just go to File, Open. And this brings us to my first speed boosting tip, is that JUMP has the ability to open multiple files at once using Open Multiple. So I've pointed JUMP to the folder where those Excel file lives. And now I'll just ask JUMP to import them in a single action. So here we go. 1,162 rows of data across over 70 Excel files. You can see their names right here, brought in with just a single click. A lot faster than you might have done it otherwise. Now, once we have our data in JUMP, or really any time you're analyzing data, the first thing to do is just look at it. Look at some basic bar charts and histograms of your data to get an idea of what's actually in this table that we're looking at. And there are many ways you could pull up some graphs in JUMP, but the fastest way lives under this gray bar icon in your data table. Click on it to reveal the header graphs, which show us bar charts and histograms that give us a basic idea of the distributions of these variables that we have here. And while we're at it, note that you can click on the sigma icon here to pull up some basic summary statistics as well. First thing that popped out at me when I brought these data in is that we have a large number of storms that were not named. And given that my superstition centers entirely around the storm's name, I'm going to go ahead and just delete those rows. All right, now to answer our question, we need to first pull out the first letter in each of these storms' names. So to do that, I'm going to create a formula column in JUMP. So first things first, let's create a new column. And of course, I could go to the columns menu to do that. But if you just want to create a column really quickly, all you have to do is just double click on an empty column header. And there we go. Now I'm going to pull up the formula editor and declare a quick formula. So if you weren't aware before, you can make formulas in JUMP like you might be used to from some other software packages. Without explaining this particular formula, I'm just going to enter in some values and pull out the first letter of our storm name into a new column. I'm going to call that letter and move that up next to storm. All right. Now, a quick aside on columns, because they're very useful and a lot of us will use, formulas. Formulas are very useful and we use them all the time. You can save a little time by letting JUMP write formulas for you. Let's say, for example, that I wanted to pull out the first date in these date ranges here as a new variable of just the date of storm formation. Instead of making a formula column from scratch, I could go to New Formula Column, and in this case, choose First Word, which is going to grab just the piece of text before the space. Underlyingly, that's a formula, but I didn't have to write it. JUMP did it for me. This is particularly useful on the front end in data prep, for example, on a continuous column, if you want to maybe do a quick log transform, or you want to standardize a variable. You can do all these sorts of things, writing column formulas, but letting JUMP actually do the work for you, and much faster. All right, last bit of data prep that I want to do. One of the first analyses that we're going to look at is actually just comparing the I storms to the average across all of the non-I storms, all just lumped together. So what I want to do is take this column and derive a new column from it that just labels I storms versus not I storms. So I want to recode this letter column. And that gets us to one of the most powerful tools in all of JUMP, one that will save you tons of time, and it's the recode tool that you can access under the columns menu, or you can just right-click on a column header like I'm doing here. So here, to recode the existing values, I'm just going to select A through H and then J through Z and click Group, Apply, a new label. We'll just call those the not I storms. I'm going to give this column a new name. We'll call it I storm, and I'll click Recode. And now we have our new column ready to go. Actions like this with recode can be very, very fast, and typically faster than maybe some other ways you might be used to doing this. Just to give you an idea of some of the things recode can do, let's say that we wanted to also extract the year out of these file names. Another great place to apply recode. So I'm going to go to recode, and without getting into the nitty-gritty of what I'm doing, I'm just going to say that I want to extract a segment of this text, everything before the dot in the .SLS. XLSX, we'll call this year. Now click recode. JMP has a wealth of data cleanup tools that can make your data cleanup very speedy. One of the things when I talk to new users that often comes up is the need for data cleanup and data preparation. And I often hear that folks fall back on what they're used to, let's say Excel. I highly recommend getting familiar with the data cleanup tools in JMP because they will save you loads of time. All right, so we're done with data prep. If you're anything like me, as soon as you bring some data in, if you have a question, you want to make a quick graph just to see what the data are telling you. So let's get into Graph Builder. And after all, no JMP demonstration would be complete without a quick trip there. Let's put letter on the X. I'm going to put max wins on the Y. I'm going to do a bar chart. I'm actually going to put max wins in the color roll as well, just to see what we can see. And so tallest bar, darkest color, sure enough, that happens to be the I storms. Now, of course, these form typically during the peak of hurricane season, but even if you look at, let's say, H and J around them, those are clearly much lower average wind speeds. And we'll get to that a little bit more in a second, but just this graph alone is telling me if I think an I storm is going to hit Tampa, maybe I should, in fact, be a little worried. But I want to do some formal statistical analyses to try to verify this. I'm never just going to take a graph at face value here. So I'm going to perform some analyses both on max wind speed and actually briefly on minimum pressure. And so I want to throw those into the distribution platform just to get an idea of those distributions. So the distribution platform, I recommend putting all of your variables that you're going to analyze in there just to make sure you understand their distributions before putting them into any more further analyses. The quickest way to get to the distribution platform actually is just by right-clicking right inside the header graphs and going to Open in Distribution. Now, when I looked at these data, the first thing that popped out at me was the skew in both of these distributions. So positive skew in the max wind speed and negative skew in minimum pressure, and negative skew being lower minimum pressure in the tail of this negatively skewed distribution being associated with stronger storms. All right, so just to verify that a normal distribution really isn't a great fit for these data, let's go ahead and pull up a normal quantile plot. Now, if you're not familiar with normal quantile plots, we're just looking for points to fall along this diagonal line that I've highlighted here. And we can see pretty clearly that these data don't follow a normal distribution particularly well. Now, I also want to do the same for minimum pressure. And I could, of course, just request a normal quantile plot. But let me show you a better way to request the same thing for multiple analyses in a window. In JMP, you can broadcast commands. That is, you can execute a command once and send it out to every other place in the window in which it's relevant. So on my Mac, I'm going to hold down Command. On Windows, you'd hold down Control. Now I'm going to click the red triangle and go for the normal quantile plot. And you can see it's applied to both variables here. So just save myself a quick trip to the red triangle there. Now there's some other customizations I want to make to this report. So I could go to the red triangle, and under histogram options, I'll find the option to disable vertical so that the histogram is displayed horizontally. And I also want to turn on the count axis. So that'd be 2 more trips to the red triangle. And of course, I could broadcast each of these commands. But instead, I'm going to reduce that to 1 trip just by holding down the Alt key. So if you hold down Alt, you can actually execute multiple red triangle options simultaneously. So now I just did vertical and the count axis. You can see right here that that's been applied. 2 trips to the red triangle down to 1 by holding Alt. So let's back up then and show you how I really would do things. If I start from scratch here, I would hold down the broadcast key. So again, on Mac, that's Command. On Windows, it's Control. I'll also hold down Alt. I will pull up the tick boxes, make my 3 selections here and click OK. And now that's applied to both variables. So that would have been 6 trips to the red triangle. Instead, it was just 1 because I know about broadcasting and holding down Alt. JMP is really flexible. You can use these red triangle menus to request graphs and analyses on the fly. And there are these little keys that you can use to reduce the number of times you have to go there. So flexibility and speed in executing it. It's a pretty good combination. Now, finally, I look at this and think, well, maybe I want this to be the default output for the distribution platform every single time that I use it, so I don't have to go to the red triangle at all. You can do that too. So if I go to the red triangle next to distribution, or in any of these jump platforms, you can find platform preferences and say that you want to save the changes that you've made as defaults for that platform. So let's save these defaults. And now you'll notice when I go to the distribution platform, those options are applied automatically for me. So I've gone from 6 trips to the red triangle in this case down to 0. Not bad. One more thing to note about Jump's flexibility and how to leverage it effectively. There are many different views or many different combinations of red triangle options that I might like to use depending on my analysis goal here. So for example, let's say that I wanted to just look at some expanded summary statistics. Or maybe I'm getting ready to place a histogram in a report, and so here's my publication quality histogram. You'll notice that what I've done is gone to this icon up here with the star. This accesses the platform presets. Once you have your report just how you like it, you could set global defaults and or save what you've done as a preset that can be applied to new data with just a single click. And so saved presets are what I've been accessing here. These are actual sample presets that come bundled in Jump. And so I can toggle between multiple views with just a single click. Or even, I'm going to hold down Command again and broadcast the selection of the presets to all of the variables in the window. So this has been a bit of a digression from our main analysis goal here, but I thought it was important to show. Again, Jump is really flexible with all the ways in which you can customize it and request new information on the fly. And these were just some of the primary ways in which you can leverage that flexibility really quickly and efficiently. But now, with that aside, let's actually get to a couple statistical analyses and again, try to figure out how bad are these eye storms really. So I'm going to go to the Analyze menu first, and I'm going to choose Fit Y by X to do the most basic analysis I can think of. I'm going to look at eye storms versus not eye storms and see if maybe those eye storms have higher average max wind speeds. So in Fit Y by X, I'll go to the red triangle and request this option, which is going to perform a basic comparison of means, a pooled t-test, if you're familiar. And here's our result. First, looking up at the means diamonds, where the center of the diamond represents the mean for each group, I can see it's higher for the eye storms than the not eye storms. Looks like that's about an 18-mile-an-hour difference, and that's a statistically significant result. So if an ice storm is heading for Tampa, it looks like it has higher wind speeds on average than all the other storms combined. But one thing I thought about here was, I really am interested in more of a true apples-to-apples comparison. That is, our not I group contains A storms, which are the first named storms of the year, or Z storms, if we ever even get to there at the very end of the year. And I'm interested in comparing these I storms to other storms that form during peak season, that is H and J. So I want to do this analysis again, but I want our not I storms to only be the H and J storms. So I want to drill down into a subset of our data. So I've met new users who very understandably think, okay, drill down to my data. Well, let me go ahead and subset my data down and then perform the analysis on the data subset. But there's a much faster way to do that in Jump. Under the red triangle, you'll find the local data filter. And so what I'm going to do is say that I want to filter on letter. I'll select H, I, and J, and now the analysis is updated automatically for me. So I can see that even with a better, we'll say, control group for the not I's, the 18-mile-an-hour difference still holds, and it's still a statistically significant result. So far, not so great for my superstition. And I should mention, I didn't cook these data. This is just what I happened to find when I went looking. But I also realized, this is just my superstition on these eye storms. I don't know if anyone else has alphabet or letter-based superstitions when it comes to storms, but I thought it might make sense to actually give each storm its own shot. That is, compare each storm or each letter to the grand mean and see if maybe there's more than just I. Maybe some other storms are stronger than average. So that analysis is known as an analysis of means. You can do that in Fit Y by X as well. So in this case, letter is going to be my X. Max winds again will be my Y. And I'm going to choose ANOM for analysis of means. And I'm actually going to do it on the transformed ranks. And that's because I found some positive skew in the distribution of these values, and I have some low sample sizes for the later bit of the alphabet, because again, it's often the case that we don't get all the way through the alphabet in each season. Now, if you're not used to reading an ANOM graph, here's how. Just look for any point that lies beyond the blue region. Any point within the blue region, we would say we don't have statistical evidence that that point is higher or lower than average. But if you're outside and colored red here, we do have evidence that you're higher or lower. And sure enough, and again, I didn't cook these data, the only letter in the entire alphabet that shows higher than average max wind speeds happens to be these I storms. And again, we're talking peak season here, but if you look at our peak season neighbors, H and J, they look pretty close to average. So I'm not particularly heartened by this finding, but it is interesting. I was also curious if it applied to minimum pressure. So if I wanted to do the same analysis, but minimum pressure is my Y variable, I could, of course, go to analyze fit Y by X and do a new analysis. But if you're ever in a situation where you're thinking, I just want to swap a different variable into the analysis or graph that I've already done, head to the red triangle, and under redo, you're going to find the column switcher. So I can say, instead of max winds as my Y, I want to be able to choose between max winds and minimum pressure. So now I grab minimum pressure, update my analysis automatically, and take a look. And thankfully for me at least, these I storms are not showing any evidence of being lower than average minimum pressure, though they are getting awfully close. But I'm going to stick with this result here, even though I kind of wish I hadn't found it. And now I want to save my work. So new jump users, very understandably, because most software works this way, you would go to File, Save, and save a separate file that contains these results. And then you could either reference the data table or embed the data table. I'm going to show you a more efficient way to save and ultimately reproduce your work. Go to the red triangle, and under Save Script, go to Save to Data Table. What this lets you do, here I'll call this ANOM for analysis of means, is write an analysis script to your data table. So let me just right-click and go to Edit. This is JSL, Jump Scripting Language. You don't need to ever see it or know that, but that's what's happening underlyingly. So we've written JSL to rerun that analysis of means. And now when I click this little green button, it reruns that analysis. And it really does rerun it. So if over the coming years I add to this data table, every time I click that green button, this analysis will reflect the most up-to-date data. So this is the most effective way to be able to quickly rerun or reproduce analyses by saving these analysis scripts. And then you have the benefit of also bundling all of them in a single file right in your data table. All right. Jump has tracked what I did. I can reproduce it easily, but that was just one analysis. What if I want to reproduce my whole analysis workflow? Well, Jump has a tool for that as well. It's called Workflow Builder. So I'm going to go to File, New Workflow. I'm going to click this Record button, and then let's actually start from scratch. I'm going to go to File, Open Multiple. We'll import our data again. I'm going to get rid of these not named storms. I'm going to do it a different way this time, though. Here's one more speed boosting tip for you. Right-click on a value, go to Select Matching Cells, and you select all those rows that match that value. I'll delete those. Make my formula column again here. So we'll substring our storm. Rename that column letter. As I'm doing this, note that all of these actions that I'm taking are accumulating in a list up here. Jump is recording everything that I'm doing. Then I can finally go to Analyze Fit Y by X. Oh, one last speed boosting tip. Well, I think there's one more after this, actually. Instead of filling out the dialog again, I'm just going to click Recall, and it'll fill it out as it was the last time I used Fit Y by X. I'll click OK. Do my analysis of means, and I'm done. So Jump has captured all of the JSL scripts to be able to reproduce every step of that analysis workflow. And so now all I have to do, start from scratch, hit play, and we did everything from data import and prep through producing the analysis. And a great thing about Workflow Builder is that it easily generalizes to new data sets. If I take this workflow and I hit play, and it goes looking for this data table and doesn't find it, it's just going to prompt me and say, what data table do you want me to run on? So go ahead and point and click your way through an analysis workflow once, and then be able to apply that workflow to new data sets with just a single click. And this might be the single biggest time-saving feature in all of Jump, in my opinion, at least. All right, so I found the answer to my question. It's not the answer that I wanted. The ice storms don't look great. But before going back to our slides, I want to clean up my jump session here. I have a few different windows open, and I could go close each one, but we began by highlighting open multiple. So now let's go to close multiple. This allows me to select any windows that are open in my current jump session, whether I want to review their changes before closing them and then just get rid of them in a snap. So how bad are these eye storms really? Well, bad enough that they are the only letter in the entire alphabet that shows stronger than average wind speed. So if one's coming for Tampa, I guess I better brace for impact. But that's not really what this was about. This was about teaching you some speed saving or speed boosting, time saving tips in jump. And so here's a list of some, but actually not all of the tips and best practices that I showed you. And there are even more than that. So I encourage you, go to the user community to continue learning. So community.jump.com. There you're going to find the recording for this talk, so you can review it at a pace that might be a little more comfortable for you. You'll find plenty of other learning resources like quick tutorials, blog posts, on-demand webinars, whole self-paced online courses. And you can also engage with Jump users who can teach you more tips and tricks along the way. It's an understandable instinct when starting out with new software to learn just enough to do the one thing that you need to do and then move on. But if you take the time to really invest in learning how to use Jump more efficiently, it's going to pay major dividends down the line. So I encourage you again to head on over to community.jump.com to continue your learning. But that's, of course, after you attend the rest of Discovery Online today. And so with that, thanks for your attention. And I'm going to pass it back to Jeff and Elisa to tell us what's coming up next.
Thank you, Ross. I definitely learned a thing or two about improving my own speed and jump. And I'll be a bit more cautious when approaching name storms and what their letters are.